Right, here are the example questions on page 17. Okay, just looking at going from like hydronium to hydroxide and pH to POH. Okay, so there's a couple different ways you can do this. Okay, if you first solve for pH, then you can find POH and then work backwards to this, or you could use like the KW divided by the hydronium concentration will give you this also. Okay, either way you get the same answer. Okay, and so like this first one here, I'll just do, so like I'll do KW divided by 5.5 times 10 to the minus 3. And we got 1.8 times 10 to the minus 12. Okay, and then to find the pH, I go negative log of 5.5 times 10 to the minus 3. Okay, and remember for significant digits, this has 2 significant digits, this has 2, which means this will have 2 decimal places, so 2.26. And then for my POH, I would do I'd do the negative log of my hydroxide concentration. So I got 11.74. All right. For asparagus, if we have a POH of 5.6, to find the pH, I can just go 14 minus 5.6, and I get 8.4. And then I'd do like the antilog, so I go like to find the hydroxide concentration, I'd do 10 to the minus POH. And so I go 10 to the second function log, which is 10 to the negative 5.6. And so this one only, because again, we only count after decimal places, we have 1 significant digit. So it's just going to be 3 times 10 to the minus 6. And now I can either use this one to solve for this one, or I can use this 8.4 and go the antilog of 8.4. And we got 4 times 10 to the negative 9. And so on. Okay, hopefully you remember doing these. We did tables like this last year. The only thing that we've added now is now we can go from one of these to the other of these using our KW formula. Okay, last year we would have had to always convert it to pH, POH, and then go backwards. Now we can kind of go on which one. Okay. Based on pH, well, we didn't find other pHs. If you want more examples, just send me an email and I can get you more examples. Okay, or I can finish off this booklet. I just don't want to make the videos too long and too repetitive. Okay, so next question here. To clean a clogged drain, 26 grams of sodium hydroxide is added to water to make a 150 milliliter solution. Okay, what are the pH and POH values for this solution? So again, we want to write down what's happening here. So we have sodium hydroxide is added to water. So it's producing sodium or aqueous sodium ions and aqueous hydroxide ions. Okay, we have this mass is 26 grams. Okay, the volume of solution, so we'll put volume over here, really doesn't matter. It's the same volume. So I convert it to liters. Okay, again, whenever we see mass, we write down molar mass. So molar mass of sodium hydroxide is 40 grams per mole. Okay. And this is just spectator ion. We don't really need that. It's a 1-to-1 ratio. So now I'm going to find the moles of this, and then I want to find this concentration. That's going to help me find the POH and pH. Okay, so I'll start with my 26 grams times 1 mole over 40 grams times 1 mole over 1 mole, my mole ratio required over given. Okay, so right now I have moles of hydroxide. I want concentration, which is in moles per liter. So I'm going to put my liters on the bottom. And then I got my concentration. So my concentration comes to 4.3 moles per liter. Okay, that's my concentration. This is equal to concentration of OH. So now if I want my POH, it's going to be negative log of my OH, so 4.3. So my POH is equal to negative 0. And I have two significant digits, so I'm going to have two decimal places. Negative 0.64 would be my POH. Okay, negative meaning it's a really high POH, which would be a really high pH also. Okay, and we'll find that here. We just go 14 minus our POH, and we get 14.64. Okay, so that would be our pH and POH, okay, of our drain cleaner solution. Okay, what mass of potassium hydroxide is contained in 500 milliliters of solution that has a pH of 11.5? Okay, so again, we have potassium hydroxide in this case, another strong base. Okay, we have our double arrows here. So it splits into K plus and OH minus. Okay, we can find this concentration using this. So first off, we have to find our POH. It's equal to 14 minus the pH. So 14 minus 11.5. So we got POH is equal to 2.5. Okay, and then to find our hydroxide concentration, it's equal to 10 to the negative 2.5. So our hydroxide ion concentration is 0.00316 moles per liter. So that's what we have here. This is our concentration, 0.00316 moles per liter. Okay, we have a volume here of 0.500 liters. Okay, again, I always convert to liters. Okay, we want to know what is this mass. Okay, this is our desired, this is our given. Okay, again, whenever we see mass, we want molar mass. Write that. And that is 56.11 grams per mole. Okay, now we're just using stoich. Okay, it's a 1-to-1 ratio again, so we'll start with our concentration, 0.00316 moles per liter. We're going to times that by liters, 0.500 liters. Our liters cancel out, so we have moles of hydroxide. We're going to times that by 1 mole over 1 mole. Okay, so this would be hydroxide. This would be our KOH. Okay, this would be hydroxide, so our hydroxide moles cancel out. Okay, now I want to get grams, so I'm going to times by 56.11 grams over moles of KOH. So that cancels with that. And so my mass is equal to, and just solve for this equation. Okay, and for significant digits, again, like this has 3, but this only has 1. Okay, so I just round to 1, so it's going to be 0.09 grams. Okay, that's how much I'd have to add to make a concentration of 11, or make a pH of 11.5 in 500 milliliters of water.